Hello everyone, this is Grade 6 Division, Chapter 6. One of the important things about recognizing in terms of division is that it is directly related to multiplication. So before I start discussing anything about division, we're going to review a little bit about what multiplication means and how we can represent it. For example, right here, I have a graphical representation of 15 times 7. I can show the 15 times 7 this way using a number sentence, and we can now solve this 15 times 7 any way we might find. For example, we could do 7 times 10 is 70 plus 35 is 105. We could do it that way. We'd be able to find an algorithm, for example, 15 times 7, and carry it out using the standard algorithm, 7 times 5 and 7 times 1. That will work as well. Of course, it's 7 times 10. However, this has an area of 105 units in a rectangle of 7 times 15. However, we can also show it a different way. If this entire length here, from here to here, is 15 units, that 15 units can actually be cut up into two smaller units. We can call it, this distance from here to here is 10 units, and from here to here is 5 units. Now, if I find the areas of the two smaller rectangles, I would then be able to find the area of the larger rectangle by adding sums. So this rectangle here is 10 times 7, which is 70, and this rectangle here is 7 times 5, which is 35. And if we add them together, we get 105, which agrees with our answer from up here, doing it all in one step. In this step here, we cut it up into 2 steps, and you'll see why further down the page. Now we're going to move on to division. However, it is very important that we do consider and we do remember what we just did for multiplication, how we can manipulate the square, or a rectangle in this case, how we can manipulate that rectangle to be able to get the numbers that we want to more easily solve the multiplication or the division question. If we go to division, I've made one more rectangle here. We can find this length right here, which is the unknown, and this height is 9 units, and the area is 153 units squared. If we had the question mark and the 9, of course, we would multiply them. So now what we want is to find what this number is right here. That's what we're looking for. However, this question calls for a division statement. The traditional algorithm that we've used would look something like this. 153 divided by 9. And you may remember that you may have been taught divide, multiply, subtract, bring down, like that. And the standard algorithm looks something like this. 9 does not go into 1. 9 goes into 15 one time. 9 times 1 is 9. Subtract, 15 minus 9 is 6. Bring down the 3. 63 divided by 9 is 7. So our quotient, the answer to a division statement, is 17. This, of course, works. This is one way that we are able to do it. However, being able to understand and being able to always be able to conduct our division, putting it in context and knowing why it works, is also very important. So I have down here the identical rectangle, and in this case, we can cut up the rectangle the way we were cutting up the rectangle for the multiplication. One way of cutting up this rectangle and cutting it into 2 smaller pieces would be working with numbers with which we are very familiar. For example, I know that 9 times 10 is 90, so I've cut up this entire rectangle into 2 smaller rectangles. One rectangle has an area of 10 times 9, which is 90. It's going to move my total area out of the way a little bit. So this is still the total area, is still 153. However, I know the area of this rectangle is 90. That means the area of this rectangle right here has to be whatever's left over. In this case, 153 minus 90. So the area of this rectangle is actually 63 units squared. So now I need some number that if I multiply it by 9 gives me 63. In other words, how many times does 9 go into 63? And we can use multiplication for trial and error. So 9 times 5 is too low, 9 times 6 is too low, 9 times 7 equals 63. So now we have the length of this piece from here to here is 10 units, and from here to here is 7 units. So the entire distance from here to here would be 17 units. This is using a graphical representation in terms of area, which most students will be able to relate to. This would still work, of course. This will give you the answer every time. However, it is a number of steps that must be repeated, and it's out of context. There is nothing relating one to the other. For example, this number here is not a 1, it's a 100. That sometimes throws some students off. Here we have another example of how we can break up 153. We don't have to use necessarily the same numbers here, but we can use, for example, 9 times 9. 9 times 9 is 81. So if I cut this exactly in half, like that, more or less, I could say 9 times 9 equals 81. So this distance here is 9. So my leftover here that was not used is 153 minus 81, which in this case is 72. So this area of this rectangle is now 72. This area is 81, and this area is 72. So I need a number that if I multiply will give me 72, which of course is 8. This agrees with our previous two responses. And right here we have some larger numbers. So once again, we can write the standard algorithm if we want of 380 here, division symbol, and then 8,360. This will work. I do want to emphasize that certainly this will work. However, putting this into a context that students will understand, in this case area, we can estimate how many times the 380 goes into 8,360 and get an exact answer from there. For example, we're just going to move the area sign out of the way so we have more space on the inside. I know that 380 times 10 is 3,800, and that would be the area right here. So I still have a ways to go, so I can do it again. I can find another 10 380s, which once again is 3,800, like that. So adding these up tells me that I'm at 7,600. That's my sum. So if I continue with 8,360 and I subtract it, that would give me the area of this piece right here. So using any method that we might use, and we have this particular area is 760 units squared. So once again, using trial and error, we can say it goes in there one time is too little, and it happens to be exactly 380 times 2. So this distance would be 2, because 380 times 2 is 760. Now once we have our entire width and our height and all of our areas, we see that they match up. If we were to add our 3,800 with our 3,800 with our 760, we get a sum of 8,360. And we broke this large rectangle up into 3 smaller rectangles, 10 times 380, 10 times 380, and then 2 times 380. Of course, it's not to scale, but the area model still holds. And that would be finding division in different ways.